Ever struggled with organizing middleware across multiple FastMCP servers while keeping authentication centralized? You'll see how to compose servers with independent middleware stacks, where a parent server handles authentication while child servers manage their own specialized middleware, all while maintaining clean separation of concerns. The pattern uses mount to create a hierarchy where parent middleware runs first, then delegates to child servers with their own middleware chains, giving you both centralized control and modular flexibility.
Hash parent server with middleware. Parent equals FastMCP. Parent. Parent add middleware authentication middleware. Token. Hash child server with its own middleware. Child equals FastMCP. Child. Child add middleware. Logging middleware. At child tool. Def child tool. SDR. Return from child. Hash mount the child server. Parent mount child prefix equals child.
This demonstrates the middleware pipeline pattern combined with server composition in FastMCP. Middleware acts as a chain of interceptors that wrap your core server logic, enabling cross-cutting concerns like authentication, logging, and rate limiting to be applied consistently across all operations. The distinctive aspect is how middleware layers stack predictably, with each layer able to modify requests or responses while delegating to the next layer in the chain. The pattern works through a hierarchical execution model, where requests flow through middleware layers in a specific order, both on the way in and on the way out. Parent servers establish global middleware that applies to all requests, while mounted child servers can add domain-specific middleware that only affects their own routes. This creates a clean separation where infrastructure concerns, like auth, live in parent servers, while business logic and its specific middleware live in child servers. This approach solves the problem of scattered cross-cutting logic while maintaining modularity. You avoid polluting your core tool implementations with repetitive checks or logging, yet still enforce consistent policies across your entire API surface. The trade-off is that middleware execution order becomes part of your architecture. You must design the layering intentionally, as later middleware can override or undo the work of earlier layers. Let's break it down line by line.
Hash parent server with middleware. Parent equals FastMCP. Parent.
This initializes the parent FastMCP server instance named parent. The server name identifies it in logs and tool registries and serves as the root for all mounted child servers and middleware.
Parent add middleware authentication middleware. Token.
This attaches authentication middleware to the parent server, requiring a valid token for all incoming requests. Middleware pattern ensures security checks run before any tool execution, protecting the entire server and its mounted children.
Hash child server with its own middleware. Child equals FastMCP. Child.
This instantiates a separate FastMCP server instance named child. Isolating child servers enables independent middleware stacks, route handling, and tool registration while maintaining clean separation from the parent server.
Child add middleware, logging middleware.
This attaches logging middleware to the child server, intercepting all incoming requests to automatically log execution details. Middleware pattern lets you add cross-cutting concerns like logging, auth, or metrics without modifying individual tools.
At child tool. Def child tool, SDR.
This decorator registers child tool as an AA callable function under the child server. The type hint defines the return schema, while the server prefix child namespaces it as child tool when mounted.
Return from child.
This defines the tool's return value, a simple string response. In FastMCP, Tool functions must return serializable data. This demonstrates the minimal viable response pattern for AI callable tools.
Hash mount the child server. Parent, mount child prefix equals child.
This mounts the child server under the parent at the child prefix, creating a hierarchical server structure. The parent delegates requests beginning with child to the child server, while maintaining its own middleware and routes. This is the standard composition pattern for building modular MCP services. Server composition pattern. The mount operation creates hierarchical server relationships where parent and child servers maintain independent middleware stacks while sharing a unified routing space. Requests to mounted paths first traverse the parent's middleware before reaching the child server's own middleware chain. This architecture enables clean separation of cross-cutting concerns from domain-specific logic.
The server that surrenders its root gains every possible path.